We'll now be exploring our first predictive model, logistic regression. So, what is logistic regression? Logistic regression is an algorithm designed to classify or predict some kind of observation in a limited number of possible predictions or categories. One example of this is your email, predicting if an email is spam or not spam. In this case, there are only two possible categories. There are many kinds of logistic regression. The first kind is binary logistic regression. This is predicting with only two categories. An example would be predicting if a tumor is benign or malignant. The second kind is multi-class logistic regression. This is predicting with more than two categories. Example would be predicting what stage a cancer is, stage 1, stage 2, stage 3, and so on. This module will be exclusively focusing on binary logistic regression. So, how does logistic regression work? Well, as we covered, logistic regression makes a prediction out of a limited number of categories. How does it make this prediction? It does so through assigning probabilities for different possible sets of categories or predictions. Now, how does logistic regression arrive at these predictions? It does so through a sigmoid or logit function. Example of one is shown on the image. Sigmoid simply means S-shaped. This refers to the shape of the function shown in the image. What is happening is that a logistic regression model is ingesting or taking in all observations and variables presented to it in the data, and then computing a prediction probability using that data. This prediction is made using a sigmoid or logit function. Now, I understand the last slide may have been dense with a lot of technical terms thrown around. I want to emphasize that the focus for this module is on the big picture. Many online resources will delve deep into the math behind logistic regression. For the purposes of this module, you just need to understand that logistic regression will classify an observation based on a limited or discrete number of categories. The math behind the logit function or logistic regression is beyond the scope of this module. Now, why would you use logistic regression? Well, it's a simple algorithm compared to some of the others you could use in machine learning. It is also not resource intensive. What this means is that computers can quickly make predictions on a lot of data. More complicated algorithms may take much longer to make those predictions for the same amount of data. Now, what are the disadvantages? As stated earlier, logistic regression is a simple algorithm compared to others. This means it may not be as powerful or accurate as other prediction algorithms available. In addition, it assumes that two classes or predictions can be teased out separately based on a linear relationship. What the heck does this mean? Look at the two charts above. The goal in these two charts is to separate the red points from the blue points using a straight line. If you look on the right, the points can be easily separated by a straight line. However, in the chart on the left, it is impossible to separate the points by a straight line. Go ahead, try to separate the blue and red points using a straight line. This means that the data in the left is a non-linear problem, while the data on the right is a linear problem. Going back to our last slide, we said that one of the disadvantages of logistic regression is that it assumes data can be separated linearly. This may not necessarily be the case.